Wherever we allow the possibility of manually entering values without a predefined dictionary, errors such as varied spelling interpretations, typos, or spelling mistakes can occur. Manually preparing such data is both time-consuming and prone to subjective evaluation. In situations where every typo can matter, the compare text procedure can be helpful. In this presentation, I will use data from a street survey conducted in Krakow. Besides questions about the topic of interest to the researcher, the survey also included a question about the district of the city where the respondent lived. An open-ended question was used for this purpose. We open the dataset Districts, which contains the responses to this question. Let's prepare a frequency table for the district variable and examine the results. As can be seen, the spelling of the districts is very varied. There are names with typos, starting with lowercase letters, or spelling mistakes. For the Biejano district, several variants appear, such as spelling without Polish diacritical marks. Our goal will be to compare the similarity of the district name spelling with the target names from our category dictionary to recode the variables accordingly. Let's proceed to the menu, Predictive Solutions, Analyze and Compare Text. In PS IMAGO PRO, we can calculate similarity measures between text variables. The procedure allows calculating 7 distance measures between text variables. The procedure allows saving the score for each selected measure and the similarity, which is a normalized value from 0, completely dissimilar texts, to 1, identical texts. The calculation method depends on the scoring method. In this example, we will use the optimal string alignment Levenshtein distance, which indicates how many characters need to be changed in one string to obtain the other. The higher the resulting value, the more different the two strings are. In the dataset, we already have a variable to which the program will compare the source variable, and this is the variable for the Biejano district. Next, in the source variable field, indicate the variable from the survey, and in the compared variable field, enter the variable containing the name for the district being checked. Then, in the Available Measures field, select the OSA Levenshtein distance. In the Add Variables section, choose the variables to be saved to the dataset. Score variable saves the distance score between the analyzed texts for all selected distance measures. Similarity variable saves the normalized similarity, range 0 to 1, between the compared text strings. The closer the value is to 1, the more similar the strings are. Let's select the score option. To perform the procedure, click OK. After the procedure is executed, 2 new variables are added to the dataset. Let's analyze the obtained data. The first case is the correctly entered name. The distance is 0, and the similarity is 1. Only in this case did the rule based on exact matching identify the occurrence of the district name in the response. In the second row, there is an error with the district name written in lowercase, and in the next row, a missing diacritical mark. Therefore, the distance is 1 substitution, and the similarity is 0.875. Subsequent cases have a distance of 2. There are spelling mistakes, missing diacritical marks, and the name written in lowercase. In the following rows, we see the names of other districts of Krakow, and as can be seen, the similarity is much lower. PS IMAGO PRO allows the user to perform in-depth comparative analysis of text variables. The ability to assess the degree of similarity between 2 text strings opens up many new possibilities for analysts in analyzing open-ended questions or comments included in questionnaires or databases. It reduces the time needed to search for variations of customer or product names, find text corrections, and assess the number of possible differences and changes.